Dark Lens Studios. Imagine standing on the surface of the moon. Above you is an endless black sky, and far away, suspended in the darkness of space, is our home, Earth. But here on the moon, there are no rivers, no lakes, no rain, and yet, hidden within this silent world, may be one of the most important resources for the future of human space exploration. Water. Yes, there is water on the moon, but finding it is only the beginning. The real question is, how will we get it? Scientists have discovered evidence of water on the moon, particularly around its polar regions. And one place has attracted enormous attention: the lunar South Pole. Here, some deep craters contain regions that receive little, or in some cases virtually no, direct sunlight. They are known as permanently shadowed regions. Inside these incredibly cold areas, water can remain trapped as ice for extremely long periods of time. But scientists cannot simply look at the moon and see huge blocks of ice waiting on the surface. Instead, spacecraft and scientific instruments study the lunar landscape, searching for clues. Measurements of hydrogen, temperature, and the composition of the surface can help scientists identify locations where water ice may be present. Maps created from this data reveal something extraordinary. Some of the most interesting signals appear close to the moon's poles, but detecting water from orbit and actually reaching it are two completely different challenges. To use this resource, future explorers may have to dig beneath the lunar surface. And that brings us to one of the biggest engineering challenges: extraction. NASA has developed technologies designed to drill into lunar soil, collect material, and analyze what is hidden beneath the surface. One example is Prime 1, the Polar Resources Ice Mining Experiment 1. Its technology included a drill called Trident. Trident was designed to penetrate the lunar surface and bring material up from below. Another instrument, called M-Solo, was designed to analyze material and look for water and other volatile compounds. But suppose we successfully locate ice and bring ice-rich lunar material to the surface. What happens next? One possible approach is surprisingly simple: heat. Future extraction systems could collect lunar soil containing ice and gradually heat it. As the temperature rises, frozen water trapped within that material could be released as vapor. That vapor could then be captured, cooled, and eventually processed into usable water. And suddenly, something hidden inside the moon's soil becomes a resource for human exploration. But lunar water could be valuable for much more than drinking. Water is made from hydrogen and oxygen. Using electricity, water can be separated into those components. Oxygen could potentially support astronauts and their life support systems. And hydrogen and oxygen could also play a role in producing propellant for future spacecraft. Think about what that could mean. Transporting supplies from Earth into space requires enormous amounts of energy and money. Every kilogram matters. If future explorers can obtain some of the water and other resources they need directly from the moon, they may not have to bring everything with them from Earth. This idea is known as in situ resource utilization, or simply ISRU. Instead of carrying every resource across hundreds of thousands of kilometers, we learn to use what is already available at our destination. And that could become an important step toward a more sustainable human presence beyond Earth. Today, when we look at the moon, it appears silent, cold, and almost completely empty. But inside some of its darkest craters may be a resource capable of helping future explorers survive, produce oxygen, and travel farther into space. Water seems ordinary here on Earth. We drink it every day. It covers most of our planet. But on the moon, water could become one of the most valuable resources humans ever find. And perhaps one day, when astronauts look back at Earth from a permanent outpost on the lunar surface, the story of how humanity learned to live on another world will have begun. With ice hidden in the darkness beneath their feet. Dark Lens Studios.